This lesson is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson 7.6b, and today we're talking about vector operations. Continuing on from last lesson, we left off on equivalent vectors, and we're going to pick up there. Okay, so the first thing we're going to talk about is multiplying vectors. To multiply a vector, let's call it v, by a positive real number, what we're going to actually do is we're going to multiply its length by the number, but the direction is going to stay the same. What we wind up calling this is scalar multiplication. So we're going to take a peek at how that's done. Okay, so scalar multiplication for a real number, k, we'll call it. Okay, that's your scalar, and a vector v. And remember that v has got to be bolded. That vector is going to equal v sub 1, v sub 2. And remember, this is vector notation, okay? The scalar product of k and v is k times vector v equals k so each component gets multiplied by the scalar. So the vector kv is what we call a scalar multiple of vector v. Okay, so let's see what that actually looks like. So let's let vector u be equal to negative 5, 4, and vector w, and again those are bolded, equal to 1, negative 1. We're going to find negative 7 w, negative 7 times vector w, 3 times vector u, and negative 1 times vector w. Okay, and what you're going to see is there is a little bit of difference when we go through these and look at them graphically. All right, so this is actually pretty simple. Let's look at the first one. We want to do negative 7w. So we take negative 7, and we essentially just distribute that through. Okay, so we wind up with negative 7, positive 7. Same thing, 3 times vector u, becomes, oops, sorry about that, that's not vector u. Negative 15, 12. Okay. And negative 1w, vector w, is going to be negative 1, 1. So as you can see, that scalar multiplication is pretty straightforward, pretty easy to do. Okay. Now, if we wanted to go through and add these, it's pretty similar. It's pretty straightforward. Okay, vector addition. So let's say we have vector u, and that vector is u sub 1, u sub 2, and vector v, v sub 1 and v sub 2. And we can say u plus v is equal to u sub 1 plus v sub 1, so you're adding those first components, and u sub 2 plus v sub 2. So pretty straightforward. Okay. Same thing goes with vector subtraction. We've got, let's say, u minus v, and we're using the same information up here. U minus v. That's going to be u sub 1 minus v sub 1, and u sub 2 minus v sub 2. Okay, so pretty straightforward. So if you were to look at this graphically, what this would look like, x and y. Let's say you've got u and v, okay? U plus v, we know to be the resultant. However, u minus v is going to be in that opposite direction, okay? So u minus v is going to be in the opposite direction as you would see the resultant. Okay, so let's try some out. We're going to do some calculations. We're going to say u is 7, 2, and v is negative 3, 5. Okay, and here's the ones I want you to do. We're going to do u plus v. We're going to do u minus 6v. (3u) plus 4v. And lastly, the absolute value of 5u minus 2u. 5v minus 2u, sorry about that. Okay, so let's start with A. All right, so u plus v, again, very basic. 7 plus a negative 3, 2 plus 5. So what we wind up with here is 4 and 7. Okay. B, u minus 6v. So we're going to do 7, 2. There's your u, minus 6 times, this is my scalar value, negative 3, 5. Okay. So I get 7, 2 minus negative 18, 30. I got to keep going here now. I got to do the subtraction piece. Okay. So now I'm going to take my first term, 7, minus negative 18, right, because we're subtracting, comma, 2 minus 30. So we know minus negative becomes a positive, which is 25. And 2 minus 30, which is negative 28. Okay, so you're just following along those operations. So let's see, so 3u, 4v, if we want, we can skip right through and do this part here. 3 times u is going to give us 21 and 6 plus 4v, and we're going to do the scalar multiplication right now. Negative 12, 20. And now we can go right to the addition. 21 plus a negative 12 gives you 8. I'm sorry, 9. My apologies. And 6 plus 20 gives me a value of 26. And there we have it. One last one to look at. And we are taking the absolute, or the magnitude, I should say, not absolute value, but magnitude if we're talking about vectors. Okay. So we're going to go ahead and we're going to do that scalar multiplication as we go through. 5 times v is going to give us our negative 15, 25, minus 2 times u, 14, 4. Okay. Now we're going to do the subtraction. Negative 15 minus 14 gives me negative 29. And then 25 minus 4 gives me 21. Okay. Now to find the magnitude of that vector, all we're going to do is we're going to take that first component, negative 29. We're going to square it. We'll take our second component. We square that, take the square root of the whole thing. So the magnitude of that is 35.8. Okay, so one of the rules that we haven't really talked about is something called the zero vector. And the zero vector is pretty simple. Basically, all you're looking at is a vector that looks like this. Okay, both components are 0. If I were to add the zero vector to something, it wouldn't change it. Just like in regular addition, if I add 0 to something, it doesn't change that. Okay, so we do have some properties of vector addition and scalar multiplication. We're going to write those out in a nice, pretty chart for you to keep in mind when you're going through these. So this should actually be pretty helpful. Okay, so this is just a list of properties. All right. So 1, u plus v, vector u plus vector v is going to be the same thing as v plus u, because we know they're commutative. U plus v plus w, and again, these are all vectors, so they should be in bold. It was u plus v plus w, so it follows that associative property. V plus the 0 vector is just going to be v. 1 times vector v is v, just like 0 times vector v is going to be 0. Okay, it follows that. I add vector v and then I add a negative vector v, we get our additive identity back, which is 0. B times C times V, vector V, is the same thing as BC times vector V. B plus C times V is going to be the same thing as BV plus BC, or CV, I'm sorry about that. So again, it holds all of those same properties as we would normally have. Okay, B being a scalar and C being a scalar. Okay, so let's talk about unit vectors next. All right. So a unit vector is a vector that has a length or a magnitude of 1. Just like unit circle has a radius of 1, a unit vector is going to have a magnitude of 1. Okay? So an example of a unit vector could be vector v, so negative 3/5. You're killing me here. Come on. And 4/5. And the way we would determine if this is a unit vector is by going through and finding that magnitude. And that's just by doing what we did just a moment ago. First term squared plus the second term squared, and it's going to give you 1. Okay, so that's how we prove if something is indeed a unit vector. All right, so let's take an example of that. Okay. We're going to find a unit vector that has the same direction as the vector -3, 5. All right, so the first thing we need to do is we need to find the length of this vector. This vector is W. Okay, we need to find the magnitude or the length of this vector in order to begin. Okay, so we've done this a bunch of times now. -3 squared plus 5 squared, which is going to give us a magnitude of square root of 34. Okay, so we want a vector whose length is 1 over 34, 1 over radical 34. Okay, we want a vector whose length is 1 over radical 34 of W and whose direction is the same. Okay, so we want it of this vector, 1/34 square root of 34th of that vector. Okay, so what we're going to say is that vector, we're going to call it U, has to be 1 over radical 34 times my vector W, I'm sorry. Okay, and we know this is a scalar number, and we know how to do this scalar multiplication now. So we're just going to take 1 over square root of 34, and we're going to multiply that in to -3, 5. Okay, which is going to give us -3 square roots of 34 and 5 square roots of 34. Okay. The vector U is a unit vector because if I were to take and find the magnitude of this vector, all right, if I were to go through this process, finding that using this vector right here, okay, we would wind up with 9/34 plus 25/34, which is actually 34 over 34, which we know is the square root of 1, which is 1. Okay, so again, all we did is we found the magnitude of the vector given. Okay, the unit vector is going to be that vector times 1 over the magnitude. Okay, that's going to allow you to have that unit vector. Okay, so in closing for this lesson, the unit vector, if I have some vector v and I know it does not equal 0, then we can say 1 over the magnitude of v times v for, this is the one we'll use most often, v divided by the magnitude of vector v is a unit vector. In the direction of v. All right, we're going to stop there for today, and we'll pick up with the rest of this lesson in the next video. All right, guys, thanks.